Okay, in lesson 3.4, what we're going to look at is some information about triangles. So we're going to start with a lot of definitions about triangles. So first, what is a triangle? A triangle has 6 parts to it. It has 3 non-collinear points connected by 3 segments. A triangle has 3 non-collinear points connected by 3 segments. A vertex is a point in a triangle. The plural of that is vertices. So we'd say a triangle has 3 vertices. We don't say vertexes. But singular has a vertex, plural vertices. The sides are the segments. So those are parts of a triangle. A scalene triangle has no congruent sides. In a scalene triangle, all 3 sides are different sizes. In an isosceles triangle, at least 2 sides are congruent. Okay? That's important to note because a lot of people think the definition of isosceles is that 2 sides are congruent. But the definition is actually that at least 2 sides are congruent, which allows for the possibility of having all 3 sides be congruent. Equilateral is specifically all 3 sides are congruent. Okay? So we can describe a triangle based on its sides. How many sides are the same? No sides, 2 or 3, or 3. We can also describe a triangle based on its angles. An acute triangle has all acute angles. An obtuse triangle has 1 obtuse angle. A right triangle has 1 right angle. Equiangular would say that all of the angles are the same size. Okay, so we have equilateral, says all the sides are the same. Lateral means sideways. Okay. Like in football, a lateral pass is one that's going sideways, right? So lateral means side. So equilateral is talking about the sides. Equiangular is talking about the angles. And then we have this term that's called an auxiliary line, and that is a line that we can add into a diagram that helps us in the proof. The word auxiliary actually means helper. So this is really a helper line. That's what the word auxiliary means. So we're going to prove this theorem 311 together. And it's something that you probably already knew, that the angles in a triangle add up to 180. Probably heard that somewhere along the way. But when you heard that along the way, a teacher just told you that's the way it was, and you said, okay, now I believe you. But what we're going to look at here is why that works. So to start our proof, the first thing I'm going to do is say, draw line DC parallel to AB. And I can do that because I'm allowed to draw auxiliary lines. Okay, so if all I had was the triangle ABC, I can add an extra line into the picture to help me out in this proof. It's just already drawn in here, but that dotted line is actually an auxiliary line. Alright, now what I'm going to do is start talking about some angles. Since we want to prove something about angles adding up to 180, it'd be a good idea to do something with angles adding up to 180. So what I'm going to do is say that the measure of angle DCB plus the measure of angle 5 is equal to 180. So if I look in the picture and locate angle DCB, that's that whole big obtuse angle, and then bring in angle 5 next to it, and all together they would make a straight line, so I get 180. Likewise, in that same step, because I'm going to use the same reason, I can say that DCB is made up by adding angles 4 and 2. What would I say my reason is for that? How do I know that I can do those things? Angle addition postulate. In both of those, I'm just adding together angles that are next to each other. It's tempting for students in this problem to just go right from the get-go and say angle 4 plus 2 plus 5 is 180. But angle addition postulate actually only allows us to add 2 angles at a time. So we can't add up all 3 angles yet. But now that we've done step 2, which says that DCB is the same thing as 4 plus 2, I can plug that in there and say what I really want to say, which is 4 plus 2 plus 5 equals 180. What would the reason be on that? Substitution, because I'm plugging something in. This would be a place we have to say substitution and not transitivity. Transitivity is this equals this equals this equals this. Here we're specifically replacing one piece. So that's a substitution. All right, so trying to keep in mind what we wanted to prove. We wanted to prove that angles inside of a triangle add up to 180. Well, that would be angles 1, 2, and 3. I'm saying 4, 2, and 5. So I'm not there yet. What can I say about angle 1 and another angle in the problem?
Angle 1 is congruent to angle 4.
Why?
Because if parallel, then AI are congruent.
Okay, angle 1 and angle 4 are alternate interior angles. So in our picture, if I have some parallel lines here, and that's what we said in step 1, angles 1 and 4 are alternate interior angles. So they would be the same. Are there any more of those in this picture?
5 and 3.
Angle 5 and 3. So since that's using the same reason, I can say that in the same step. So now, if angle 1 and 4 are exactly the same, I should be able to swap them out whenever I want. And if angle 5 and 3 are exactly the same, I should be able to swap them out whenever I want. And so then I can turn what we said in step 3 into the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, which is what we wanted to prove. The angles inside of a triangle add up to 180. And what would our reason be there? Substitution, because again we're doing that swapping. We're replacing pieces of what we said in step 3. You probably already knew that we could add up the angles of a triangle and they add up to 180. If you didn't, that's fine because now you do. Okay? When you knew it before, it was probably because somewhere along the line a math teacher told you that's what it was. But now we can see actually why it works the way that it does. Okay? So in tonight's assignment, you're not going to be working with proof. You're going to be working with this fact that we can add up the angles of a triangle and have them equal 180, and some more facts. And these facts are listed as corollaries. A corollary is defined as kind of like a middle ground between a postulate and a theorem. So remember, a postulate is something that we can't prove, we just have to accept. And a theorem is something that we can and should prove. A corollary is kind of the middle ground. It's like we can prove it, but it follows so directly from a theorem that we just usually don't. It's just a natural progression from a theorem. So we're not going to prove these, but they are going to be important facts in solving some of our problems. So the first one says, if two angles of one triangle are the same as two angles in another triangle, the third angles have to be the same. Well, if each triangle is supposed to have 180, and I've used up the same amounts in each of them, I must have the same amounts left over. So that kind of makes sense. Corollary 2 says, each angle of an equiangular, so all three angles are the same size, should be 60. Well, if there's supposed to be 180 inside of there, and they're all the same, 180 divided up by 3 is 60. So that makes sense. Corollary 3 says, in a triangle there can be at most one right angle or one obtuse angle. Why? What would happen if I had more than one right or obtuse angle? I'd already be up to 180. So if I just had two right angles, I've already used up 180 degrees, so there'd be nothing left over for that third angle. So that can't work. An obtuse angle is even worse. So the most we can have is one right or one obtuse, because otherwise we're using up too much of the 180. And corollary 4 says the acute angles of a right triangle are complementary. What does complementary mean? Add up to 90. So if I have a right angle, I've used 90. So the other two must add up to 90 as well, so that altogether I have 180. Okay. So all of these follow directly from the fact that the three angles of a triangle add up to 180. Questions? We have one more theorem, which we're not going to prove, but will be important in solving your homework problems. It says the measure of an exterior angle of a triangle. To make an exterior angle of a triangle, what we do is extend one of the sides out in one direction. And that creates an angle outside. I cannot extend that line in both directions, so I could not extend it out to the left as well and say that's another exterior. Okay, all of our exteriors can only go out one side. I could do more exteriors if I wanted. I'm not going to want this for our picture, but just to show how that would work, I could do another exterior up there, and I could do another exterior down here, but it has to kind of look like a pinwheel. Okay, I can only extend the side out in one direction and call that an exterior. Okay, I cannot take that same side and extend it out the other way. Okay, that does not work to be called an exterior. Okay, so like this picture is a no-no for exteriors. Okay, so that'll be important in some of your homework problems where you'll need to draw some things. Okay, but back to this problem. The measures of an exterior angle of a triangle, so I'm going to call this angle 1, equals the sum of the measures of the two remote interior angles. So inside of a triangle, I have 3 angles. This tells me that that outside angle, which is angle 1, should equal the sum of 2 angles, the remote interior ones. Which ones would those be?
2 and 4.
3 and 4.
2 and 3.
Oh, we got lots of disagreement here. So let's think about what the word remote means. What does the word remote mean?
The thing to control TV with.
Okay, so a remote control is an example of where we hear remote. What does remote mean? Or a remote village?
Separate.
Distance.
It's a distant or a separate thing. Okay, so when we hear the phrase like remote village, that means this place is in the middle of nowhere. A remote control controls your TV from far away from it. So we don't have to get up and press buttons on our TV anymore like we did when I was a kid. Okay, so remote means far away. So now thinking of remote meaning far away, which angles are the remote interior angles? 2 and 3. The ones that are not right next to it. Now I said we're not going to prove it, and we're not, but let's think about why it works that this is true. What do I know about angles 2, 3, and 4? They add up to 180. Inside of a triangle adds up to 180. What do I know about the angles 1 and 4?
They add up to 180.
They add up to 180. So I could do some substitutions here and find that since 4 is a part of both of those groups, that 1 should be equal to 2 plus 3. Okay? This will be an important fact that you'll use in some of your problems on your homework. Questions? All right, so always, sometimes, nevers. We saw these a little while ago in an assignment. We said that if it's going to be always or never, it's probably coming straight from definitions or theorems. Okay, either actually being a definition or theorem would give us an always, or contradicting a definition or a theorem would give us a never. Otherwise, there's a whole lot of gray area for sometimes. Okay, if we can draw multiple pictures of a situation, that's going to give us some options for sometimes. If a triangle is isosceles and it is blank equilateral, what did isosceles mean?
2 sides are
What did isosceles mean?
2 angles.
It means that all 3 lines are 3 sides.
Isosceles.
At least 2 are congruent.
Unless 2 sides are congruent.
Okay, so there's an important phrase that a lot of people are leaving out, the at least. Okay, isosceles means at least 2 sides are congruent. What does equilateral mean? All 3. So if at least 2 sides are congruent, are always, sometimes, or never all 3 sides congruent?
Sometimes.
Sometimes. Sometimes a triangle could be both isosceles and equilateral. That all 3 sides are the same. That triangle is both isosceles and equilateral. Because isosceles is at least 2 sides. If a triangle is equilateral, then it is blank isosceles.
Always.
Always. Because equilateral means 3 sides and isosceles means at least 2. So if 3 are the same, then at least 2 are the same. Always. If a triangle is scalene, then it is blank isosceles. What did scalene mean?
They're all different.
They're all different. So if they're all different, then is it possible that 2 or more are the same? No. If a triangle is obtuse, then it is blank isosceles. What does obtuse mean?
Over 90.
One is
One angle bigger than 90. So I could have one angle bigger than 90 and have two sides match up. Or I could have one angle bigger than 90 and not have two sides match up. Questions? We have some problems to solve here. So in these, it's going to be helpful for us to remember that the angles inside of a triangle add up to 180, or that an outside angle is the sum of the two angles that are far away from it. So in the first one over on the left-hand side, how big is x? 90. That's an outside angle. It should be the sum of the two angles that are inside and not touching it. In the upper one on the right, how big is x? 105. It's an outside angle, so it should be equal to the sum of the two angles that are inside and not touching it. Be careful with the bottom one on the right. X is outside, so it should be equal to the sum of the two angles that are inside and not touching it, but we don't know what those are. So what do we need to do first?
Find the opposite of 40.
We need to find the angle that's next to the 40. How do we do that?
40 from 30.
Subtract from 180. So they're on a straight line. So on a straight line, two angles should add up to 180, so we can find that inside angle is 40. And now we know the two angles that are inside and not next to x, so we're going to add those up. And what do we get?
25.
75. So be careful because we get in the habit of like, oh, I just add these two, I just add these two, I just add these two, I just add these two. Make sure you're adding up the right two. Okay. Questions? Please notice that there are some odd questions in your homework. There's actually a lot of odd questions in your homework, so make sure you only do the odds, otherwise you're doing a lot more work than I'm asking you to do. And since I know odds are in the back, let's just have a little refresher of something we talked about the first week of school and the difference between checking and copying, right? Checking your answers means that you've done the problem and you're confirming you got it right. And if you didn't get it right, that you redo it until you do get it right. And if you can't figure out how to get it right, that you accept the fact you got it wrong. Okay? Taking that answer and saying, oh, that's not what I got, but that's what the book says, that becomes copying. Okay? All clear on that?
Clear.